Okay, welcome to lesson 4, the dot product. So let me refresh your memory a little bit by a reading quiz. So suppose you are given a vector p and q, and the angle between the two vectors is theta. Okay, so what will be the dot product of the two vectors p and q? Okay, it should be as easy as pq times by cosine theta. Okay, the answer should be B. Okay, and number 2, the dot product of the two vectors result in what quantity? Whether that's a scalar, vector, complex, or zero. Okay, the answer should be the scalar. Okay, that's the dot product. So another question, if the dot product of two non-zero, okay, vector is 0, then the two vector must be whether it's parallel, perpendicular, or cannot be determined. So think about it. If the two non-zero vector is dot product is 0, so we know the p vector times q equals to p times q times by cosine theta. Because it's a non-zero vector, the p and q, its magnitude are not 0. Okay, which means the only way to make this equivalent to 0 is to make the cosine theta equals to 0. And when cosine theta becomes 0, when theta equals to 90, it becomes cosine theta becomes 0. So if the theta becomes 90, we can say the true vector is perpendicular. So that's why the answer is C. Another question, okay, question 2. If the dot product of two non-zero vector equals to minus 0, so the vector must be what to each other? So similar, if the vector p and q is dot product equals to p's magnitude times by q's magnitude times by cosine theta. Because p and q, they are non-zero vector, which means p's magnitude and q's magnitude, they are not zero as well. So which means the cosine theta will be equals to -1. So the theta will be 180 degrees. So which means there will be the two vectors, they are collinear, but their direction is opposite. Okay. So here's an example. Let's given the force acting on the hook at the point A, and we want to find the angle between the force vector and the line AO. Okay, so how to get the vectors, the angle between two vectors? So in the previous slides, we know the P times Q equals to PQ times by cosine theta. So we can know the cosine theta will be equals to P, vector P times vector Q over P's magnitude times by Q's magnitude. The theta becomes by the reverse of P times by Q over P and Q's magnitude. Okay, that's exactly our plan. So how to, first we need to find the RAO and find the angle by this equation. Okay, what's the vector of the RAO? we know the x coordinate is 1, -2, and 2, and O's coordinate is 0, 0, 0. Okay, the RAO will become the O's coordinate minus A's coordinate, which becomes -1 times by I plus 2 times by J minus 2K. That's we get the RAO. And what RAO's magnitude? It's a square root of x squared plus y squared plus z squared. It becomes 3. And the vector f is already given. Here is a vector f, and also vector f's magnitude is this equation. Okay. Please use a calculator to check whether the f's magnitude is 11.22 kilonewton. Okay, so next step is to calculate the f vector times RAO. So the dot product of the two vector will be the coordinate of x times by each other plus coordinate of y times by each other, and the coordinate of z times by each other. It will become 18.18 kilonewton meter. Okay, here the equation. And the theta becomes the reverse of cosine theta. And here is the f times by RAO, which is 18. And also the vector f's magnitude is 11.22. And the magnitude of RAO is 3. So we can get the theta becomes cosine reverse of 18 over 11.22 times by 3. Okay, you can pause the video a little bit and check whether the final answer is 57.67 degree. So what's the unit vector of AO? It will be the vector AO divided by RAO's magnitude. We know its magnitude is 3, so it becomes 1/3, -1/3 plus 2/3 times G minus 2/3 of K. And the FAO will become the F vector times by unit AO. Okay, so the FAO becomes by -6 times by -1/3 plus 9 times 3/3 plus 3 times by -3/3. Okay, because the F is negative I, 9G, and 3K. Okay, so the vector, the FAO becomes 6 kilonewton. Okay, or we can calculate the FAO as F times by cosine theta. So which is the F vector's components on the FAO x, which becomes 11.22 times by cosine theta. The answer is the same, still the 6 kilonewton. Okay. The quiz for today. What's the dot product of the two vector P and Q? We know the P is 5i plus 2j plus 3k. Q is minus 2i plus 5j plus 4k. The answer becomes P times Q equals to 5 times negative 2 plus 2 times by 5 plus 3 times by 10 by 4. Negative 10 plus 10 plus 12. The answer become 12. So which means the answer will be C.